All right, everybody. So hopefully this is working. What we're going to be doing is I'm re-recording the previous lecture, which was not the homework. It was on the programming assignment, which let me find it. Here it is. So it was on programming homework 4, and I was going to help walk you through the a lot of the code here. Okay, so here's what I think I'm going to do. Um, So in the original video, which has no audio, which is why we're re-recording it, I coded up this function, MakeCircuit, and I said that we would code up RemoveEdges next time. And so I think what we're going to do is I think we're just going to code up both of these right now, and yeah, and that way it's like a 2-for-1 deal. Rather than having to record 2 videos. And I think I can be more efficient than I was last time and hopefully not make an hour-long video on this. So let's go ahead and get started. Okay, so first thing is you need to have watched the other lecture probably. So watch the first lecture to understand the algorithm in 10.5 for finding an Euler circuit. In a graph. Okay, so that's not what we're doing in this video. In this video, we're assuming we already know the algorithm and we're just going to try to code up the individual parts. Speaking of which, take a look at this. So you've got this function here in problem 1, function circuit equals Euler EG. I'm calling it the graph EG because we're storing the edges of the graph. That's how we're doing it. It doesn't make a difference if you use EG or G, so don't worry about it. But this is how I wrote it. And the point is that this function right here is complete. Okay, this is the algorithm for finding an Euler circuit in a graph. Okay, so Euler, EG, is the function for finding the circuit. So we're done, right? No, we're not done, right? We're not done because the function Euler calls a bunch of other functions, right? It calls this function called MakeCircuit. So we need to write that one, right? Nope. Euler calls, what's it called? So first it calls a function called MakeCircuit, and then it calls a function called RemoveEdges. I guess I'll actually just put this here, the whole thing. That did not do what I wanted. Life is hard. Then we have to code up RemoveEdges. We have to code up find circuit. And find vertex that rather. And then we have to code up merge circuits. Okay, and that's what you do in problem 1A through 1 whatever. So A, B, C, D. 4 functions to code up, right? So this is 1A, 1B, 1C, 1D. All right. So that's what we got going on. Is we have to code up each of these functions here. Okay. And so we're going to code up, I think, the first 2 today. So let's try to do that. So first of all, what does MakeCircuit do? Well, in order to know that, we have to understand how we're going to have our graphs organized. So we're going to have our graphs organized in pairs of edges. So like if you look at 1A here, it says that we should test our code here. So like, let's take a look at this. So if I take this graph, which is what it is. I'm going to just paste it into the command window in Octave. Take the semicolon off so we can see it. And there you go. So this is how we're going to represent a graph in Octave. So graphs are written like this in Octave or MATLAB. Now, what's that mean? Right? So what this means is that the 1, 2 means that there's a edge between vertex 1 and vertex 2. 1, 4 means there's an edge between vertex 1 and vertex 4. 1, 3 means an edge between vertex 1 and vertex 3. 1, 3 means an edge between vertex 1 and vertex 3. So there's actually 2 edges between vertex 1 and vertex 3, right? That's a multiple edge. That's allowed. 2, 4, there's an edge between vertices 2 and 4, 4 and 3, 4 and 5, 5 and 3. Okay, and that's how we're going to represent it. And so if you actually wanted to know what the vertices are, you'd actually have to look in here and see how many vertices there are, right? So we have a 1, a 2, a 3, a 4, a 5, and so there's 5 vertices. So this right here represents a graph with 5 vertices and 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. 5 vertices, 8 edges, and these are the 8 edges. Okay. Now, normally when you're looking at graphs drawn by hand, you're seeing them often the vertices are A, B, C, D, E. Like if I look at the PDF and scroll down, often the vertices are this way. That's fine, right? All you've got to do is you just take this picture and you apply your own numbering to the graph. It doesn't matter what vertex you call what. Obviously, the thing that makes sense is just to say A is 1, B is 2, C is 3, D is 4, and so on. But there's no reason to. You could just put 1 right here, call F1, call I2, call C3, call J4, whatever. It doesn't matter at all. But you just put your own numbers on the vertices, and then you would be able to type in the graph by just listing all the edges. Like on this graph, for example, vertex 1 to vertex 2, that's an edge. So you would start out by saying 1, 2 in your down here. And then there's an edge between vertex 2 and vertex 3, right? B and C, right? And then one from 3 to 4, and then one from 2 to 4, right? So you have all these edges that you just type out, but you have to apply a numbering to it. You can't use A, B, C, D. I mean, you could if you wanted to write more complicated code, but we're not going to. So that's how you represent the graph on the computer. Okay, so that's what this is. Now, once we have it, let's talk about what the find circuit function is going to do. Now, first of all, you have to remember what a circuit is. I hope you do. So a circuit, what is it? Is a path, right? Which is a list of edges that we follow in order. That goes through, that uses every edge once. Well, actually, a circuit, it doesn't use every edge once. A circuit just is, like A to B, B to E, E to A. That's a circuit. So it's just a sequence of edges that ends up back where you start. And they have to all be adjacent, right? Like A to B, B to E, E to A. That's a circuit. A to B, H to J, that's not a circuit. Because we didn't use the edges in between, right? So you have to go around. It's only a circuit if you follow the edges. So we have circuit as path that, well, okay, I'm not going to write what a circuit is, but a circuit is a circuit. So what we need to do is we need to find a circuit, okay? And there's an easy way to do that. So an easy way to find a circuit So an easy way to find a circuit in a graph, assuming it has one, right? Because not every graph has one. you can actually, one definition of a tree is a graph with no cycles. So, keep that in mind that not every graph has a circuit, but if a graph does have a circuit, then what you do to find a circuit is you just start taking edges this way. So let me find a circuit in this graph right here, for example. Here's what you would do. So if we call this function, right? Let's say this is the function we're calling. Okay. So what it would do is the 1 is where we want to start. So we're going to start looking through this list for a 1. So you look through the list from the beginning for a 1. Okay. Now you could use any number there, 1, 2, 3, 4, 5, but I called it with a 1. So that's what we're doing. So we're looking for the 1. You're going to find a 1, right? You find, what do you find? Well, you're going to find this right away, right? 1, 2. That's what you're going to find. So you find the edge 1, 2. Okay. Well, you were looking for the 1. You found the 1. Now you're going to be looking for the other vertex in there. You're going to be looking for a 2. Now look for a 2. You find, now when you do this, you have to keep in mind that what you're going to do is after you've used an edge, that edge is gone. Okay. So like if we found the 1, 2, then now that's unusable. Okay. So now you start at the beginning of the graph again, and you're looking for a 2. So you start at the beginning, you look at 1, 4, 1, 3, 1, 3, 2, 4. You found a 2, right? So you find 2, 4. Okay. So you found 2, 4. Now that you found 2, 4, we found the 2. So now we start again, but we're going to be looking for a 4. Right? You're always looking for the other vertex. You find the 2, now you look for a 4. So again, we're starting from the beginning. So we found this edge right here, right? So that one's gone. So you start at the beginning and we're looking for a 4. So you look here, you find 1, 4. That's what we're looking for. Okay. So now if we're following this pattern, you would look for a 1, right? Because we found the 4, so we would be looking for the other vertex. So we would be looking for a 1. But we are not going to keep going because we found a 1 and that was where we started. So we started at a 1 and we ended at a 1. And that's a circuit. Since 1 is what we started with, we're done. The circuit that we found is all of these edges that we listed here. So 1, 2, 2, 4, 1, 4. Oops, 1, 4. And that forms a circuit because this is vertex 1 to vertex 2 to vertex 4, and then it says 1 to 4, but 1 to 4 and 4 to 1 are the same thing. So 1 to 2, 2 to 4, and then 4 back to 1. So start at 1, end at 1, and that's a circuit. Okay, so that's actually a pretty simple algorithm, but there's gonna be some issues that we run into. So let's try to write this code here. Okay. Yeah, let's try to write the code. So if I look in my PDFs here, got MakeCircuit. It's supposed to start this way. I mean, it doesn't really matter if you copy all my stuff, but here it is. We're not going to go there. We're going to go to Octave and we're going to write it here. So I have an empty MakeCircuit because, of course, I wrote it in the previous lecture, so I erased it. So here's how we're starting. MakeCircuit. And we do have this practice graph here, so we can see how we're going. So what are we going to do? Well, one thing that I know we're going to have to do is we're going to have to keep track of what? Well, let's look at our code here, not code, but our practice. So the first thing you're going to do is you look through the list from the beginning for a one, right? So that means the vertex that I'm looking for, I need to keep track of. Okay. So you've got this V, that was the starting vertex, right? I'm going to call that start V is V. So that's the one we're starting with. We're going to keep track of that because the way we know we're done is when we're back to the start. So we keep track of what the starting vertex was. Also, we have a current V. You know, you can use whatever you want for the variables, but I'm going to do it this way. And when we start, we're also going to be looking for that current V. Okay. Now, what are we going to do? So what we're going to have to do is, you know, we're going to keep going until we find a circuit, right? So how are we going to do that? Well, we need a while loop, right? So something like while the starting V is not equal to the current V. That's basically what we want, right? Because we want to stop, like when the thing that we're looking for down here at the end, we're looking for a one, that's the current V, but one was where we started, that's the starting V, and that's how we know we're done, right? The starting V is one and the current V is one, that means we're done. The only problem is that's also true at the beginning, right? At the very first step, we're looking for a one, and that was the starting one as well. So kind of a cheating, not, I won't say cheating, but kind of a cheating way to do this is I know that this is what I'm looking for to end my while loop. However, I would like to get into the loop one time to start with. So like, you know, you can have a variable called like first or something like that. And so you can say while the starting V is not the current V, and, or I guess, or, huh, wait, no. What do we want here? Or first is one, right? So, and then the first time we get in here, we can set first to 0. And then that way, what'll happen is we get into the while loop once for sure, but then after that, these are going to have to be different. Otherwise, we're going to get kicked out of the loop. There are other ways to do it, but like we could just return when we're done, I guess. Now, what else could we do? Our return variable is circuit. Let's make a circuit. We're going to just make it empty to start with. Okay. All right, so far so good. So let's go in here and write this code. So what we want to do right now is we're going to get in this while loop. And when we get in this while loop, what we're going to be doing is we're going to be looping through the edges of the G, looking for whatever we're looking for, right? So the first time through, we're looking for a 1. But like if we were looking for a 5, we'd have to go through this edge, this edge, this edge, this edge, this edge, this edge, find it in edge 7, right? So we're going to have to loop through all of the edges of G. So you need to know how many edges there are in G. So what we're going to do is we're going to have to calculate that. So let's just do that. Let's say, well, how are we going to calculate the number of edges? So the number of edges is actually the number of rows. So in order to keep track of that, like if I do length EG, it says 8, right? Because there's 8 edges. So you think, okay, I'm just going to loop from 1 to 8. and that's going to work. But it's not going to work because if you have like some other graph, let's call it like G2 or something, that only has a single edge, and you ask for the length of G2, you would want it to say 1 because there's one edge, but it's going to say 2 because there's two things in here, and it doesn't know that you're supposed to be counting rows, so it counts columns. So you can't just use length here. If you want the number of rows of the matrix, you're actually going to have to ask for the size of EG, which is 8 by 2, and then know that you're looking for the first number in that list, and that's going to be the number of rows. So in the code here, where's the code here? Somewhere. Click editor, that's how. This is where you would need to calculate that number of edges, right? So what you would do is you would say, like, let's say maybe size EG is size EG, clever naming convention. And then the length of EG, like number of rows or number of edges, so maybe number of edges is going to be whatever that size is, first component, right? So the first component is where that 8 is going to be. Okay, so now I have the number of edges. Now that I have the number of edges, I can loop through the edges. So I can say for I equals 1 to number of edges, like that. Okay. And I'm just going to do this. I'm going to go, let's see here, EGI. So right now, this code, of course, is not doing what we want it to do, but I think it will get into this while loop because first is going to be 1, and then it'll go through this loop here and just display all the edges. So it'll do something now. So let's try that. So let me just run this. So this is called MakeCircuit EG, and the 1 is not used for anything, but there you go. You said 1 1 1 1 2. Oh, okay. I put EGI, but we actually want the ith row every column. So ith row every column, that's the entire row. So like if I save this and run this again, then what it did was it just, it just spit out the edges back at me, right? Like EG was this. Oh man, Octave is not being very cooperative with me right now. But anyway, right, like you see the 5 3, the 1 3. What happened to the 4 3? Okay, so like 1 2 1 4 1 3 1 3 2 4 4 3 4 5 5 3. So those are the edges just spit out on the screen. But that's not what we're supposed to be doing with them, right? We're not supposed to be spitting them out on the screen. What we're supposed to be doing is what we said here. We're supposed to be checking if we can find that vertex, right? We're looking for a 1. So you need to check that row for a 1. If you don't find it, check the next row for a 1. If you don't find it, check the next row for the 1. So that's what we need to do. So this is the row that we need to check, but how are we going to check it? Well, we're going to check it. So we're going to say if EG I comma 1, right? There's a two edges there, or sorry, two components there. There's the first column and the second column. So if the first column is the thing we're looking for, which is current V, then what do we want to do? So what do we want to do? Man. If you find the 1, we want to do two different things. You need to take this entire row, and that's part of the circuit, the 1 2 down here. And then we want to update the vertex we're looking for, right? When you find 1 comma 2, the new current vertex is 2. So we're going to be looking for a 2. So let's do that. So if that's the case, then the new current vertex that we're looking for is going to be this. Now see if this makes sense to you. So if we find what we're looking for in the first column, then the new thing we're looking for is in the second column, right? So that's what we want to do. What else do we do? Also, this entire edge needs to go into the circuit. We're going to be copying it there. Circuit end plus 1, I'll do that, comma. So this is going to be whatever the next row is. We're going to be adding a row by using end plus 1 every column, and that's going to be the current edge. The current edge is EGI comma colon, right? This is how we spit it out to the screen. So of course this is what we call it down here. So that adds the circuit to that adds it to the circuit basically. Okay. Now what else do we need to do? Well, the other thing we need to do is we should actually delete it from EG. Now that we copied it into the circuit, I want to remove it from EG. That's because, remember how this worked. After you find the 1, 2, we're not supposed to find that 1, 2 again. So that's what the X's were for, right? Indicate that I already used it. Now, rather than keeping track of which ones we used, it's just easier just to remove it from the list, and then you don't have to worry about, whether or not you used the edge already. You just remove it and it's gone. So that will remove it. So we update the current vertex, we update the circuit, we remove the edge from the list of edges, and we're done. But the first column is not the only place where you could find it, right? Like when you're looking for a 1, the 1 might be here in the first column, but it also could have been in the second column. So you have to check the second column as well. So that would be if EG I comma 2 is the current vertex. And if that's the case, you want to do all the same stuff, but it's all going to be reversed. So like if you found the vertex in column 2, then the new vertex is in column 1. And well, I guess that's it. That's the only thing that's different. So we did that. Let's end this and I'll run it to show you what it does now. It's not done. Let's run it. So save it. Let's run it. Error. Why did it do that? Oh, I know why it did that. It did that because we deleted it from the edges, but then we didn't. We deleted it from the list of edges, but did not update the number of edges, right? So there's a lot of ways you could handle that. The main thing is that actually, if you remember how we did this on paper here, is once you find the thing you're looking for, you go back to the beginning of the loop, right? You don't keep going, right? Like if I look for a, let's just say, pretend I'm looking for a 5, right? If I go through this list here and look for a 5 and you find it right here, then the next thing I'm going to do is not look at 5, 3. The next thing I'm going to do is I'm going to say, okay, I found the 5. Now I'm looking for a 4. You go back to the beginning of the list to start looking for the 4. You don't keep going. So the way you can do that here is say, after we do this stuff that we need to do when we find the vertex we're looking for, actually you break out of the loop. And this break is going to break you out of this for loop is what it'll do. And you need one down here as well. So what'll happen is you'll delete the EG. It will kick you out of the for loop. which means you'll end up back at the beginning of the while loop and it will recalculate the number of edges, and we should not get that error that we just saw. Save it and run it again. Okay. So 1, 2, 2, 4, 1, 4. That looks like what we were trying to do actually, doesn't it? 1, 2, 2, 4, 1, 4. Let's just make sure this works no matter what. So you can make a circuit starting at any vertex you want. So if I check with a 2, it finds 2 to 1, 1 to 4, 4 to 2. Okay. What if I want to start my circuit at 3? It finds 3 to 1, 1 to 2, 2 to 4, 4 to 1, 1 to 3. 4. 4 to 1, 1 to 2, 2 to 4. Okay. 5. 4 to, or 5 to 4, 4 to 1, 1 to 2, 2 to 4, 4 to 3, 3 to 1, 1 to 3, 3 to 5. Starts at 5, ends at 5. Now, when we're looking through these, keep in mind that it doesn't reorder the edges. So like you say to start at 5, it's not going to put a 5 in the top left. It's going to put it, you know, if it was found in the second column, it's still going to be in the second column. So you have to interpret the results, right? This means we're starting at 5 going to 4. This means we're starting at 4 going to 1. You know, but when we were doing 1, 2, when we started looking for vertex 1, we started in the upper left corner, right? Because it's not reordering it. But if you interpret the result, it's still clear that we found a circuit. And I think that worked, right? We just checked it and it worked. So awesome. Now, what will happen though, we can get in trouble if we do this. So if you do something like that, oh, okay, never mind. I was going to say that we could get into an infinite loop or something, possibly, but I guess we can't. If there was no circuit, that's what I was implying there. So like if I make a, oops, keep doing that, command window. So if I do like G2 and I just go like 1, 3, 1, 3, 3, 2, 2, 5, right? There's no circuit there. It goes from 1 to 3, 3 to 2, 2 to 5, and then it stops. So if I call MakeCircuit G2 with a 1, infinite loop. Okay, so it went 1 to 3, it found the 3 to 2, it went 2 to 5. Now there's no more edges, but it's still going through here, waiting for the starting vertex to be not equal to the current vertex, which is never happening because there is no circuit. So we want to have at least a minimal amount of, you know, error correction there, not correction, but we don't want an infinite loop. So I'm gonna hit Control C, stop that. And how could we stop this? So the problem is, you know, when we did this, it found 1, 3, 3, 2, 2, 5. And then after that, it's looking for a 2, but all of these vertices are gone. So there's no 2 left because we already removed all the 2s. And so what we need to do is, if you actually go through all of this for loop, which is here, and you don't find what you're looking for, then we're just done and we can't keep going. Okay, so where do we want that? No, that won't work. I think what we need to do is if the number of edges is ever 0, is that what we want? Let me think. No, here's what we want. So you loop in this for loop through looking for the thing that you're looking for. If you make it through to the end, without finding what you're looking for, then you need to just break out. Okay. So how would we do that? I'm trying to think of a good way. I can't really think of a good way. Um, Trying. Oh, I know. No, I don't know. We'll just check. Um, so if I is the number of edges, so what's happening is this. So you're checking for the current vertex in position 1. You check if the current vertex is in position 2. Okay. So if you get down here, that means that you did not find um, that means you did not find it in position 1 and position 2. So if you did not find it in position 1 and position 2, and I is the number of edges, which means that we looked through the entire list, then we just need to return because, we failed in our mission here. So I'm adding in, so we have an if it's found in the first component or first column, if it's found in the second column, and then an else, and the else only is going to happen if I is equal to the number of edges. That would indicate that we looked through the entire list without finding what we were looking for. We should return. Okay, and it'll never get here to this else. It'll never do this if statement unless two things are true. It's on the last edge because I is the number of edges, and it already did not find it in the first and second spots. Okay. A lot of ends in a row. End. Save. So hopefully no infinite loop. Nope, still an infinite loop. Wait, that doesn't make sense. What did that happen? Huh. I don't know what's going on here. I'm going to split out the I, and I'm going to split out the number of edges. And I'm going to see why that did not happen. So let's do that, and let's hit run. Oops. Okay. We're never getting here. How could that be the case? This is very confusing to me right now. I'm going to do an end here. I don't think this is going to do what I want it to do, but it'll do something. And then we can debug it. Huh. Why is this not displaying anything? Okay. All right. So what's happening is I is 1, the number of edges is 2. And it's displaying that repeatedly. How could... Okay. I should have just written this the way that I wrote it previously. But I'm going to print out that. We're going to run it again. We're going to look at the result and we're going to figure out what's wrong. Okay. So, wait, quit. Let's just run for a second. Hit Control C. Uh, okay, I think we get it. So I is 2, the number of edges is 2, and I is 1, number of edges is 2, I is 2, number of edges is 2. Okay, so we are getting into the, like, at some point, I is 2 and the number of edges is 2, which means I should get here. But we weren't, and I don't know why. Whoa, 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 whoa. Okay. I think maybe I don't know what I did. If number of edges equals I, did I put like one equal sign or something dumb? It's always possible. All right. Hopefully we still get a bunch of what's on the screen. Yes, awesome. So it is getting in here, but I want to return is what I want to do. And for some reason that wasn't happening before. Okay. I could have sworn that this was the exact code that I had before. Maybe I'm wrong. So here's what I think I'm going to do. We are going to return here, but also the other thing we're going to do here is I feel like if there is no circuit, we shouldn't pretend that there is one. So I'm going to return an empty thing. There we go. Okay. So now, what? And we broke it again. How did we break it again? All right. Oh, one is not in the else. Oh, wait. We're never in the else? We never get in the else. How is that possible? Makes no sense to me. I've been doing something wrong here, but I do not know what. We're never getting into the else. So, do this. All right. Oh, I is 1, the number of edges is 3. I is 1, the number of edges is 2. I is 1, the number of edges is 1. Uh, and then it hangs. Uh, uh, okay, figured it out. Figured it out. So This code works um, sometimes, but not always. Let's do this. No. All right, number of edges, current V, and the I. No, not the I. We can figure this out. Why is it hanging? Okay, so it's hanging because the current V is 5, the number of edges is 0, current V is 5, and the number of edges is 0. So the number of edges is 0. Oh, okay. I really know what's going on now. So what's happening is it doesn't make it here when the number of edges is 0. So it never gets to that. Never gets to that. So we need to do something specifically. We can't do this here. I think we'll have to up here if num edges is 0, then what do we want? Probably just to return. Okay, that should do it. If it doesn't do it, whatever. It didn't find a circuit though. So this isn't guaranteed to always find a circuit. If there's no circuit, it won't find it. So that was really long and tedious, and we didn't even do very much. But there we go. Anyway, so here is a MakeCircuit that will work. It worked a long time ago, but could get into an infinite loop. It should not be possible to get into an infinite loop anymore. We need the code down here. Same thing. And an else. All right, fine. There we go. At this point, it should now no longer be possible to get into an infinite loop as it is doing right now with no trouble at all. Dang. RemoveEdge is 2, I is 2. Isn't it what I just had here? I don't know. Okay, whatever. Now there's no infinite loops. So that's so dumb to have to put this here and here. The way I wrote it in the previous video was better, but we got it done. Okay, so that's done now. So here it is. Copy it or write your own. That's better. That would be nice. And let's look at the next function we have to write. So the next function we have to write is going to be RemoveEdges. And this is a much easier function to write. How is it supposed to work? So if you look here, what you're going to do for remove edges is basically this. So you're going to have like a return variable, which doesn't have to be called h. We're actually probably going to return EG. It's probably what we're going to do. And this is a very, very simple thing. Here's how it's supposed to work. So suppose like EG is this. So let's go like 1, 2, oops, 1, 2, 1, 2, 2, 3, 4, 6. One more, 5, 2. Okay, suppose that's EG, and then circuit is, and I'm not even going to worry about whether circuit actually is a circuit. That's not important here. So let's say it's just 1, 2, and 4, 6. Okay, here is all that remove edges is supposed to do. So you're supposed to take this EG and remove the edges that match circuit. So like you see a 1, 2 in circuit, right? And there's a 1, 2 right here. So you remove that. So remove. Okay. Then you see a 4, 6 down here. So you remove that. And then what do you return? Well, just this, but with the stuff that you're supposed to remove, removed. So this line gets removed. This line gets removed. Now, one thing you want to pay attention to is 1, 2 was in the circuit, right? 1, 2 was in the circuit, and I'm going to remove a 1, 2 from EG. But I'm not going to remove both of the 1, 2s. You only remove one. If you wanted to remove both of them, then there should have been 2 in circuit. If there were 2 in circuit, we would have removed 2 from EG. But there's only 1 in circuit, so we only remove 1. Okay? So that's why I put a repeated edge there. Okay, so that's all that remove edges is supposed to do. Hopefully you can see this. It's pretty straightforward. Okay, so let's go ahead and write this code. So I think I have pseudocode for it in one of the PDFs. Let's look for it. Here it is. Remove edges. So basically you have to loop through. You have to loop through the edges of EG or G, and you have to loop through the edges of the circuit, both of them. So let me change this a little bit. So we're going to call it with EG, and we're going to return EG. So the way I'm doing that is I'm actually going to remove the edges from EG rather than store them in some other variable. Okay. So let's go ahead and do this. So notice that I wrote this all in pseudocode. This is pseudocode, so you can't, where's the break? So this isn't actually MATLAB code here, so keep that in mind. I'm just gonna leave it here for reference, and then when I think I'm done, we're gonna delete it. So first thing, from 1 to the number of rows of circuit, how are we gonna do that? Well, we need to know the number of rows of circuit. So we do that the same way we did it here with this, this kind of code, right? Get the size, then get the number of rows. So we need the number of rows of circuit. So what we're going to do is something like this. Get the size of C, just for circuit, is the size of circuit. And then the number of edges, well, I'm going to call it rows of circuit. So I'll call it rows C or num rows C, but I'll just call it row C. That's going to be size C, comma 1. All right, so this will be the number of rows. Also, I can see in the next line that I also need the number of rows of EG. So we do the same thing. with EG, 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 EG. So like right now, let me just comment this out. Right. At this point, this code doesn't do very much. It's just calculating the number of rows of C and EG. So like if I go EG is 1, 2, 2, 3, 3, 4, right? 3 rows. And if my circuit, which maybe I'll just call it C, is like 2, 4, 2, 4, 3, 4, right? And then I call my function, which was called RemoveEdges, EG, comma C. And oh, it didn't. Oh yeah, C has 2 rows, EG has 3 rows. That's all we're doing so far is counting up the number of rows. So EG has 3 and C has 2, and that's what is being reflected here. And it returns the entire EG, which is wrong, but we haven't done that yet. Okay, so now let's actually copy this. This is really straightforward here. We just need to write it like this, but in real MATLAB code, because this is not real MATLAB code. So first line says for I equals 1 to the number of rows of circuit. That's what we're calling row C. For j equals 1 to the number of rows of EG. For j equals 1 to the number of rows of EG. If circuit I comma colon equals, which, you know, needs to be like that, then what do? We delete EG comma, or sorry, EG j colon. That's the j row. So we're looking, we find the row that matches the circuit, and we're supposed to remove it. So delete that row. How do you delete a row? We did it in the other function, but all you do is you just say that row equals empty brackets, and it deletes it. And then once that happens, you don't keep going, right? Because remember when we wrote this in Notepad here, when you find the row that you're looking to delete, you delete it, but you don't keep looking for the same row, right? We don't want to delete 1, 2, and 1, 2. You only want to delete the first 1, 2. So we should, after you delete something, you break. Break. And that breaks out the loop. And then we end the if statement. And then we end the for loop. And then we end the other for loop. And you could have an end for the function, but you don't have to. So I think this is it. Let's see if it works now. So actually, let's do our example from here. This is a possible EG. There it is. This is a possible circuit. Copy paste it. If we remove the edges, EG comma circuit, we get 1, 2, 2, 3, 5, 2. 1, 2, 2, 3, 5, 2. That's what we're supposed to return. So it works perfect. So we've got this function RemoveEdges, which was much easier to write. MakeCircuit is definitely the hard one to write here, just because it's not hard to start putting rows into circuit, but it's hard to make sure that you stop all the different ways that you can stop and, you know, avoid the infinite loop and that kind of thing. So this was a little bit awkward, but we managed to do it eventually anyway. And we also did the whatever it's called, RemoveEdges. So we'll look at the other functions in another lecture, probably Friday. Okay, and yeah, that's it for now.